So thanks everyone for joining us for this Social Science Data Lab today. Just a short introduction what the Data Lab is. It's an event series where we provide a platform for tools and methods for the collection and management, analysis, visualization for the data in social sciences. And it's organized by myself, as well as my colleagues Dennis Cohen and Julian Bernauer, and with the support of our student assistant Nick Baumann. Today, we're very happy to have Theresa Küntzler here. She's a PhD candidate at the University of Konstanz, and she will talk us today through how to extract emotions and more from faces using R. Just some quick logistics before we get started. I also posted it in the chat. So you can ask questions, and we are very happy to have questions. We will have a short Q&A after the talk, and you can do that by several ways. The first one, you can either raise your hand in the Zoom chat, and then we will call on you and you can speak and unmute your phone, or you can post questions in the chat and we will read them out loud, or you can send us also the questions via DM and we're gonna read them anonymously. So, and again, all this will be recorded, so your questions will be also on YouTube. So then I would say the floor is yours, Theresa. I'm gonna mute myself and you can start.
Thank you very much. Thank you so much for having me. I'm super glad to be here and there today. I'm gonna share my slides. I hope everyone can see them fine. As Cosima already said, today I'm going to talk about extracting emotions and more from faces with Face++ and Microsoft Azure. I plan on starting with a little introduction on why we even care about images and faces. And then I'm mostly going to talk about the code to get information from the Face++ app, a little bit about how to adjust it for Azure because it's really easy to just transfer it. And I'm also going to do a little live demo. If you have questions, feel free to ask them during the talk, really, because often with code, it's just hard to follow if you kind of missed a little bit or something. So really feel free to ask also during the talk. First of all, let's start why we should even care about images. There's a saying that says a picture is worth 1,000 words. And when I was looking for images to show you how images are important and contain a lot of information, there was a tiny problem that's called copyright. So I can only show you images here that are not copyright protected. This is basically the drawing of a picture that has been made, and I think most people will already recognize it. This is a drawing of a boy whose name was Alan Kurdi, and he did not survive the fleeing of his parents. He was drowning in the Mediterranean Sea and swept onto a beach. And this image, or this picture of this boy, really traveled the world, and I'm pretty sure you already have the original picture in your minds. So just by showing this picture, there was so much information transported. There's a second image to show you how much information a picture can give, is this one. I'm also pretty sure people already realize the person behind this iconic hand gesture. It's Angela Merkel, and this gesture is very important to her. She does it all the time. It contains a lot of information, and it even is so important and so iconic to her that for one election, there was a huge election poster on the train station in Berlin. So here also politicians or in politics, these images are really used to transport a lot of information and way more information that you could put in just a slogan. Facial images are basically a subgroup of the image as data question. And why should we care about facial images as data? First of all, humans generally infer a lot of information from faces. When you see a face, you immediately have an idea about how old this person is, what gender that person has, what race that person belongs to, but we also infer stuff like competence or how attractive we find the face that we see. And those are variables that are relevant in a political science context. For example, if you let people judge competence just based on faces, this can be used to predict who wins an election. So if you have two candidates and people judge how competent they think these candidates are only based on their face, of course, it's not a perfect prediction, but it's better than random. And then a little more recently, Yo et al. Did a similar thing, and they used machine learning tools. So they basically programmed a computer, or they created an algorithm to extract stuff like attractiveness, competence, masculinity from images or from faces, and use this to predict election outcomes in the US. We can also infer party affiliation from faces, so people do that. And this again, so this the party affiliation that we infer is biased if we find a person more attractive. So whenever we find someone more attractive or more competent, we tend to project our own political affiliation onto this person. So here really, I'd like to show that the faces of people contain a lot of information, and people use this information to make political decisions. The problem that we had up until recently in analyzing any sort of images, but also faces, is that it's really difficult to code. So if you want to do a large scale quantitative analysis, you need a lot of data. So first of all, you need to collect a lot of images, but then you also need to code them. You need to figure out, put a number on how attractive is this person, what's the scale, what's the value of this person's attractiveness or emotion or gender. Gender is more or less easy to code, not entirely easy, but it's rather possible. But still, it takes a lot of time and training. So here, computer vision really put the analysis of images forward. Computer vision is the science of making machines learn to tell what is visible on an image. So to computer, images are basically a series of numbers. There are multiple ways how to store images as numbers, but it's more or less always a matrix of digits. And computer vision, as I said, is part of machine learning, with the two most important parts are object detection. So where is an object on the image? Is there this object even on the image? For example, find the face on the image or find the dog on the image, and then classification, which would be the next step. If a face is found, is it a male or a female face? Is it a happy or an angry face? And then what machine learning, the basic idea of machine learning is finding structures in these series of numbers. And whenever something is doable by a machine, you can scale it. So machines are able to detect faces and classify them in a certain way with a speed, so way faster than humans can do it, we can scale it. And this is what we use in social science now. So we apply the computer vision techniques that are developed by others. And then the other little bit more technical part is that I said I use an API. Very basically, an API is a set of functions that allows us to access an offered service. So here I use a web API, so it's a service online. And the very basic format is we write a certain code that is supplied to the API together with the image. We send it via the internet. The API runs the program and gives us the output. It's kind of how it works. Now, what are the two APIs that I'm going to talk about today? The first one is Face++. This is the one that I'm going to talk mostly about. I wrote down the edges here, and Face++ offers more than what I'm going to talk about today. So they have all sorts of machine learning services, and the sub-program that does the facial analysis is the face detection API. In my research, I mostly use the emotions. So I care most about what emotion is seen on this face. Is this person showing a happy face or angry face? But there's a multitude of variables that you can ask the API to get a score for. For example, age, gender, whether the person is smiling or not. The API can give you a certain beauty score and so on. Face++, as it is a company, so they try to make money, of course, and they sell their services, but there is a free account, which includes technically unlimited usage, but there are possible capacity restrictions. So when there are a lot of requests from paying customers, they will deal with the free customers less quickly. You can have only one key per account. I'm going to explain in a minute what exactly a key is, but it basically means that you can only make one call at a time. You can always just send one image at a time, as long as you have only a free account. And you have a certain amount of storage limits, which is not really important if you do what we're going to talk about today. For other services, this is more important. And of course, if the free account is not sufficient to your needs, you can pay for improved services. And then the second API that offers something very similar is the Microsoft Azure Face API. It has a different address. Again, the Microsoft Azure service offers way more than just the Face API, but the Face API is the part that I'm using today. There's, again, a huge list of variables that you can get information for. I should state that the emotion, which again I deal with, for Face++, it gives you scores for 6 basic emotions plus a neutral category, and Microsoft Azure gives for 7 different emotions plus the neutral category, so there's a slight difference here. And then there's a little bit of variation in the variables that are offered, but most of them are the same. So again, it's gender, age, you have a value for smile. What it does give you, what Face++ does not do, is something like head pose, for example. Here again, you can pay for the service. There is also a free account that's restricted to 20 transactions per minute. One transaction would be sending 1 image, so you can get information of 20 images per minute and 30,000 per month. If you use them up, you need to wait until the next calendar month or pay. But this is definitely sufficient to do research. So I'm doing my research only with the free accounts. You just might need a little bit more time. Okay, so let's start the walkthrough. How do you actually use these services? The first thing you need to do is get access credentials, which basically means registering and get a username and a password. For Face++, you can register here. I put the link behind this text, and they're all going to be in the YouTube video. Or if you need them right away, you can send me an email and I can share the slides with you so that you have all the links. So first of all, you register, you log in, and then you go to the console, apps API key, and you click get the API key. This is just in the menu, very easy to find. And then for Face++, you need to fill out a little form. Most of this, it's really a short form. Most of this is you can choose a name for your app and stuff. And the important thing is to choose between whether you want a free API key or a standard API key. And standard here means that you pay for it. Free is the free account that I just talked about. And you submit. And then you can see your personal API key and secret. So this is a tiny screenshot. It's not so important that you can't read it properly. It's just to show that this is where you would have your key and the secret to just copy and paste later on into the R code. It's important that you treat your key and secret just like any other username and password. So this is personal to you. It identifies you and you shouldn't share it with others, just like any other username and password. For the Azure API, it works basically in the same way. Again, you need to register. Here, Azure has made a nice little instruction with images, how to create your API key. And then what is the console for Face++ is the portal at Azure, so just a different name. And then you can click on the key icon, and this is where you see your personal API key. Azure only has a key, so it's just not the combination of key and secret, but just a key, basically just a username. And it looks quite similar. Again, here where it's blacked out, this is where your personal key would be, and you could copy paste it to your code later on. So this is the first part, and that's basically all you need to set up the code that I will supply. So it's the key, the secret, and then of course the image that you would like to have the information for. Before I start with the actual code, I'd like to lay out the structure of the functions, because it's a lot of code, but the structure is actually quite straightforward. It's two functions. First of all, the authentication function, which is only needed for Face++. This is more of a convenience thing. There are different solutions how to deal with that. But since for Face++ you have the key and the secret, this is a one-line function that takes those two pieces of information and saves them into one R object that we can then pass on to the actual API call function. The call function is a little bit bigger, but also really straightforward. What you need as input is a vector with file paths to the images. All of this code is written so that you can send images that are stored on your machines. You could technically change that to images and provide a URL to images that are online, for example. But in this case, the functions are written for images stored on your machine. So you need a file path to every single image that you would like to send, and then your authentication data. And this is really just whatever comes out of this function, just the R object. Those are the two inputs you need for the call function. And what you get out in the very end is a data table with one variable stores all the file paths, and then the output data of the API for every single image. So what's going on in the function? In the first step, an empty table is created to fill with the API output. This empty table has one line for each file name, so one line per image, and the name of it is called faces. This will come up a couple of times in the following slides. Then a big for loop is started, which basically says, do the following for each image. So take every file path and do the following with it. First of all, just make the call. And then if at least one face is found in the image, because it could always be the case that you provided an image where there is no face, or where the API did not detect a face. The API might always be wrong. So if at least one face is found, first of all, write the first face into the output of the data frame. Remember I said the faces data frame has one line for each image. So first of all, it has space for a single face. If more than one face is found, add lines to the data frame and complete the information in the data frame. After you did that for one image, wait 2 seconds before the next call. This is especially important for the Face++ because there, for the free account, we can only do so many calls per minute. And I just tried how to get the wait time as low as possible, and I figured that 2 seconds is sufficient to only make 20 calls per minute. And for Face++, this is not necessarily not necessary technically, but I made the experience that the function runs just smoother and more stable if we have the weighting. If you did that for every single image, so when all the images were sent to the API and you have the information, in the end return the faces data table that is now filled with everything we wanted to know. And that is basically all. So the setup is really straightforward. And now let's look at the code. I'd like to highlight this little note that this function and parts of the next function were written by a colleague. His name is Sascha Göbel. He originally introduced me to Face++. We were talking about my research and he said, hey, I know about this and this might really help you out with your research. And he also provided me with the basic function of the authentication function and also the Face++ code. I changed the code quite a bit, but the basic version is from him, and I don't want to take credit for his work. So this function is completely written by him, and this is really just where you put in your key and your secret. So this is copy-paste from the registration page that I showed you before. You plug it in here, and this is just structuring and making a list of your two authentication objects, making one single R object out of it. This is basically the simple function. And then going over to the actual call function. This function is called faceest. And as I said, the two things you need to input is a vector of the file paths. This is called full path. So this should be one object where all the paths to the images you would like to send to the API are stored in. And then auth is the authentication object, which is the output of the function we just saw. Those are the two only arguments you need to provide to the function. So the first part is basically data preparation. All this slide is data prep. First of all, we initialize an object that's called face with null. Just to get the terminology straight, face will be the object where the information of a single image is stored in. So this is the output of the API. And then faces is the data set that contains the information of all images. The faces data frame here is, as said before, simply initialized as a data table. It contains one value for each variable that we would like to store. In this version, I'm asking the API to give me information about the emotion of the face and the gender of the face. So for each emotion, anger, disgust, fear, happiness, neutral, sadness, and surprise, we have one variable. In the documentation of the API, it states that the value is a numeric value between 0 and 100, so we initialize the variables as numeric. Gender will be given as a character, so the value will be either male or female, so this variable is initialized as a character. Face count is a variable that is created by the function itself. It just indicates how many faces are found in an image. That's a variable that is needed for the data storage process. And I also needed it for my research, and just in general, never throw away information that you have, so why not just store it? And then lastly, there's the full path variable that's just filled with the full path object, which is the same that you provided here. And this line makes sure that you have one row in your data frame for each image. So at this stage, the data frame is basically empty, except for the full path variable that just has one line for each full path that you provided. Note this little sign here. This just means that the code is going to continue on the next slide. So there will be a few slides where I present this whole function, and it's all one function. And here you also see it on top here, so it means there's some code that happened before. Now this is the slide that goes over the actual call. But first of all, there's a little service to the user basically. I initialize a variable that's called run with 0. This will later be used to just print for every single image, print a number at how many images have been sent. I like to see that my code is still running and working, and sometimes if you send a lot of images, this function can take hours or even days. And then it's just nice to know what number are we at, how many images have been sent. I think it's a matter of taste if you want your code to print out the stuff. If you don't like it, you can just delete it. In this line, the big for loop is starting. So this here says for I in one to length full path. So if we provide, if you want to make a call for 4 images, we provide 4 paths to the images. So this would go from 1 to 4. Basically, this line says, let's go over every single image. First thing is add 1 to our running count and then print a count to the console. This is where we just get the information, just sending the next image. Then we make the actual call. So remember, we initialized face in the beginning with null. So while it's null, the following code is running. And this here is the core and the actual call, this one. So here we write the face variable, which will then contain the output of the API. And we're going to have a closer look at this now. This is a zoom in, same code. So we have face, and the face object should be at the end stored as a character. And then we use the HTTR package and the retry function. There are multiple ways of doing this. You could also do it with a post function. And Sasha made the choice of using retry. There are multiple ways to get there. This is just one option. So use the retry package, which allows you to send multiple calls. If, for example, the first call to the API failed for whatever reason, it just tries again before completely failing. Now, all the information provided in this function is taken from the reference manual. Again, there's a code link behind this, and that specifies the information for the function. Here, we need to completely adhere to what the API needs as information. First of all, we need to decide the request method. There are only 2 options with APIs. You can either post or get. Those are 2 messages. And here on the side, you see screenshots from the reference manual. And here, clearly, the reference manual states request method is post. So we copy paste and use post. The next step is we need to supply the request URL. So where should this call actually go? What is the address of the API, basically? Again, in the reference manual, here is the request URL, and this is, again, just copy paste. And then in the next step, we look at the body. The body is where we provide all the additional information that the reference manual states is needed or that the API wants to know. First of all, here we have, again, the screenshot from the reference manual, and there are multiple request parameters. Some of them are required, some of them are optional. The first required one is the API key. As I said before, that's our authentication. This is why you need to register. So we use the exact same wording, the exact same writing that they use here in the manual, and write key and assign it our key. Remember, auth was the argument you provided to the function. So you take your auth object and specify the key. The same is happening for the secret. Exact same writing, API secret, and then from the auth object, use the secret. And then what's also required, but only choose any of 3, is whether you provide an image URL, an image file, or an image base 64. As I said earlier, you can use this to provide the URL to an image online to get the information, the file, or base 64. Base 64 is a different version of saving images. We use the image file. So just the file path. So here we have image file, and then use the upload file function in R, and the full path I, which is the full path we're currently making the call for. Remember that this is part of this huge for loop that we do for every single file. And then lastly, there are a couple of optional arguments to the function. So one is the return landmark. You can get different facial landmarks from the API. You can either get a lot of them, some of them, or none. I decided that I don't need them, so I supply the integer value 0. And then lastly, it's called the return attributes, the last argument. And this is where you can choose the different variables that I also listed priorly. This function, I'm asking for values for emotion and gender, but you could also add age or whatever you feel like into this string. It says here it should be a string. So we have the 2 quotation marks in R to make sure that we provide a string. And what took me a while to figure out is there should not be a space after the comma here. This is really important because otherwise it doesn't work. And often in R, you usually add a space after the comma. Don't do it here. It takes forever to figure that out. At least it took me forever.
Can I quickly ask a question?
Yes.
So what about the landmark? Can you give me an example of what that is? Is it is it a virtual landmark that it returns, or is it?
No, it rather tells you where exactly, where you have an eye, where you have the nose, where you have the mouth.
Okay. Thank you.
You're welcome. Right, and then the last 2 code lines here belong to the retry function again. So it says retry 2 times, up to 2 times if it doesn't work. And then the encoding format is multipart. This is a very general way of encoding whatever the API sends you back. And then in the very end, whatever comes out of it is stored as a character into the face object. Now this is very abstract. So let's look at what the face object itself would look like in R. I send the test image to the API, and this is what face would look like. Sorry. Those who are used to working with APIs or online formats, they will recognize this as a JSON notation. JSON notation is very common, and it's basically a long string that is structured to very specific rules. And this is really nice because anytime something is structured to specific rules, it's easily readable by machines, and it can easily be transferred from R to Python to whatever you want to. So this is a very general format. And already in this string soup, we can find the variables that we were looking for. So for example, here we have emotion, and then there's anger with a value, disgust with a value, happiness with a value. And obviously the API judges that this person on the image is really happy. In addition, there are some more information. For example, the face token. This will be used in a second. Imagine there are multiple faces found in an image. Each of these faces gets basically an ID. Here it's called face token. So this is supplied by the API. Later on, you could do more with this face token within the API. In this code, I'm just using it to count the faces. By now, there's also face num, but when I first wrote or first worked with the API, this variable did not exist. So probably there would be an easier way to count the faces, but you can just also count how many face tokens, how many face IDs are there in the image. As I said, JSON is a very common format, a very systematic format, and luckily R, of course, also has a package that helps us read this and make useful R objects from it. It's called JSON Lite. So now let's move on to storing all the information that we have. First of all, just look at this little part here. So the from JSON function comes from the JSON-lite package, and when you give the string formatted in JSON format to the function, it outputs an R object. It outputs a list, and in this case, it outputs a list of data sets. So we can access subparts of this list with the $, which is usual in R. So now I'm creating this face count variable that indicates how many faces there are seen or there were found in the image, which, as I said, is happening by counting the face tokens, the face IDs. So we structure the face object with the from JSON function, go into the faces subcategory, and extract the face token. Moving back to this word soup, we take the face object, go into the faces category, take the face token, and count them. In this case, it's just 1. So we would have the face count variable assigned 1. Now, since a face is found, we check if a face is found. So the face count cannot be negative. There cannot be less than 0 faces in an image. So this basically says if there's at least 1 image found, start the storing procedure. And then first we want to extract the emotion and the gender. This works again in the same structure. So we take the face object, read it systematically with the from JSON function, go into the faces subcategory, into the attributes subcategory, into emotion. Looking back at this here, it would be go to faces, take the face object, go to faces, attribute subcategory, and then emotion. The emotion part contains values for anger, disgust, fear, happiness, neutral, sadness, and surprise. And then if we do this, you see here what the R object emotion would look like. So this is what's created in this line from the image I showed you. So these are the exact same values: 0 anger, 0 disgust, a tiny, tiny, tiny little bit fear, but actually really just happiness, no neutrality, no sadness, and no surprise. If there were 2 faces found in the image, this object would have a second line with the information of the second face. The same is happening with gender, except that gender just has 1 value instead of 7 here. So we extract the emotion and the gender as a nicely R object that we're used to and write it into the data table that we prepared before. So we use the faces, which was the empty thing that we prepared earlier. We make sure that we take the line of the full path that we're currently dealing with, and then we fill the first to the 9th variable with the first row of emotion, the first row of gender, and face count. As I said, we just start by providing only the first face because we only have 1 row per image in the data set. And this is also a bit because how the code was written. In the first place, it was only meant for images where there's 1 face. So the addition of, oh, there could be multiple faces just came later. But still, for my code, most of the time there's only 1 face. So I just left it like that. And then for the possibility that there are multiple faces, we have to add lines to the data frame. This is happening with a second if loop. So if the face count is larger than 1, if more than 1 face has been found, we override the faces data set. We're using the union function, which is really nice because it makes sure that there's no double rows that are identical. And then we union the faces data frame as it was before, which already contains the first face of the current image, because we already had that loop. And then we create a second data frame that's called Y here, or data table, that has all the information of all faces from the current image. And as I said, union makes sure that the first face that has been found and is already written into the data table, but is also in this data table, is not doubled. And that is basically it. So now there's just some bookkeeping left. This here ends the face count loop. And then we have a bit of bookkeeping to do. So we reinitialize the face variable to be null to store all the information for the next image. And we wait for 2 seconds before we make the next call. This bracket ends the if loop that was for the case that there is any face found. If there was no face found in the first place, there was nothing to store. So the face object would definitely would directly be set to null again, have a system sleep of 2 seconds. This loop then ends the for loop from the very beginning. So we end up here when we went over every single image, every single full path that we wanted to. And if this is done, just return the faces object. So return the data table that was initialized and is now filled with all the information that we wanted. And that is it. So most of it is data wrangling, and only a little bit of the actual actual API call. If we don't want to use Face++, but the Azure API, there are a few modifications necessary, but it's really not a lot. So first of all, we need to adjust the variables in the faces data frame to whatever we want to use. But if you stick with emotion and gender, you need to add a variable for contempt. As I said earlier, this is the 7th emotion variable that Azure provides a value for, whereas Face++ does not. And then what I added is Azure gives you error messages if something goes wrong. For example, if you exceeded your monthly limit in the free account. And I wrote a little addition to the function to make sure to keep the error messages just to know what's going on. Sometimes if the image is too small or too large, there would also be an error message that helps you figuring out what's wrong. Of course, if you change the faces data frame, you need to adjust the saving procedure accordingly. If there's one more variable to be filled, you need to fill it. And you also need to adjust the actual call. Remember, the call entails the URL, where to find the API, and your key. I figured we saw enough R code, so this will be on the blog post and possibly also on GitHub for you. If you need it right away, you can also email me. But these are really minor changes. Nothing changes in the logic. So I decided to leave it at that for today for the talk. Maybe more importantly, I decided to do a little live demo for you. And it's really quick, just to show that after all of this code explanation, it's actually really not that difficult. So let me move to R. As I said earlier, the authentication is personal to you, so you should not share. This is why I already stored the information of my key and secret into the my auth object so that you cannot see it, but I can use it. So what would you actually do if you just took the code that I presented here? You have to load a couple of packages. Then you need to load the authentication function. You also need to load the face estimation function. You see that it's the same code that I just showed you, just in one nice R page. Then what you would do is use the authentication function. You would paste your key and your secret here. And then the object would be stored in myAuth. As I said earlier before the talk, I did that with my information already. And then you would call the faceest function. I already created a file path object that contains a path to 2 images. One is the Obama image, and sorry. The other one is this image. So I chose an image where you have 2 people, so you can see what the data frame looks like if there are 2 faces. Quickly going back to R. So all you would have to do is provide the file paths and your authentication details to the faceest function. You can run it. You see it says I'm on the first image here. Now I'm on the second image. It takes a second, and then we can look at the faces, which is the output. And you see it has 3 rows now. Here we have the full paths. So there's the Obama image that you already saw, and then the 5-Kampf. That's the screenshot that I just showed you. Gender seems to be right, so Obama is male, and the 2 other politicians we saw are female. And then we have values for the emotions and the gender and the face count. So it says in the Obama image there's 1 face, 5-Kampf is 2 faces. Let me go back to the slides. Before I'm done, I'd like to add a word of caution. So I think this all seems really nice and cool, but there, of course, to any method, there are downsides. So first of all, these algorithms remain black boxes. As I said, both Face++ and Microsoft Azure are companies, and they will not share with us what is going on behind the scenes. They do not share their parameter values of the algorithm with us. So we need to really make sure that it's performing well on our data. I think you should always, when you use it, have some hand-coded data to check your accuracy in your specific case. Also, I'd like to hint towards the general problem of racial biases and other biases in computer vision in general. So for example, one data set that a lot of these algorithms are built on is the ImageNet data set, and there nearly 45% of all images come from the US. So if you base an algorithm, make it learn based on images that are very US based, then it will be very good at figuring out what's going on in the US. This is also something you might have to consider for your research, and you should be aware of. And then lastly, some of these variables are very subjective. Of course, the API gives you a score of how beautiful is this person or how competent is this person. But just remember that this is something subjective, and you need to figure out how this relates to your research. What does it to whatever you want to say in the end. This is really just, you should know about it and then see if that affects your research or not. And then also words of caution on the law. For these services, I really advise you to read the terms of service, figure out what's happening with your images if you upload them, and also make sure that you're allowed to send the images you want to send. Those might entail stuff like copyright issues, personality rights. So just make sure that what you do is legal. I have the impression that with images, you need to be even a little more careful than maybe with texts. Yeah, so that's the end of my talk. I hope you enjoyed it. If you have thoughts, ideas, or questions, feel free to contact me. I'm just going to make sure it's in the recording, switch to the references and to the links to the images because they need to be shown at least once. And then, yeah, thanks for your attention. If you have questions, let me know.
Thank you very much for the talk. So if anyone has any question, again, you can either post them in the chat, send us, like me and Dennis, a direct message, or you can also raise the hand. Perfect. So that's the first one. I was just saying, like, I'm going to start, but we can do it like that. So Lena asks, thank you for this insightful talk. I've worked with the Microsoft algorithms in the past, and I'm comparing the results to other available algorithms. Have you compared the classification of emotion expressions between the Face++ and Microsoft algorithms? And if so, how similar or different are the classification results in your experience overall and with regard to the emotion expressions? That's an excellent question.
Super interesting question. And I'm happy that people ask this question because I'm working on a paper to answer that. So far, it's still work in progress, and I'm pretty surprised at what I can say preliminary, that there are quite some differences. So far, I have the impression that Azure is getting the emotions of the pre-coded data sets a little bit more right. And I'm still trying to figure out where this difference comes from. It might be also due to the data that I use, so there's a little bit more to do. But I would definitely say that we should not take the output values as completely for granted. There is space of error. But if I had to choose, I would say the Azure API is a little bit better on the emotion scores. I haven't looked at other scores, and I would be interested to see any papers, any work that goes into this direction, because there's so little being done in comparing them and seeing how good they actually perform. So if you work on that, please send me an email or anything. That would be really interesting.
That's cool. I do have a kind of follow-up question, because I was asking myself during the talk how reliable these fine-grained emotions are. So I would say, or I would assume that if you have something like positive and negative emotions, that should be more or less easily detectable. But how about this, like anger or probably surprise is also easy, but like how reliable are these like different levels of emotions?
Mm-hmm. Yeah, I mean, the answer to that question would probably be quite similar. So I think you can deal with the outputs kind of like you can deal with them with probabilities. I think Face++ is giving you for every emotion a score between 0 and 100, but the scores add up to 100. Face++ does the same on a scale from 0 to 1. And I think you should deal with them with probabilities. If it's very divided, then there's a lot of uncertainty in the game. Whereas, for example, with the Obama image, it was pretty certain that this was a happy image. And then if the algorithm is that certain, I think we can trust it quite well. But of course, the Obama image was also a very placed image and not something that we usually encounter in our daily lives or in talk shows or with regular people. And then there, it gets a bit more difficult to figure out how large has the value to be so that we can trust it. Mm-hmm. That's also something I'm still trying to figure out with the paper. I hope I'll be able to tell you more about it in a couple of months.
Yeah, I'm definitely looking forward to it. So there's another question by Dennis. He asked whether you can say something about applications in social sciences, and also if these algorithms only work on static images or also on videos. Yeah,
one more thing I'm working on. So general applications in the social sciences, we see some of them coming up in the US. One paper I saw is they looked at how the different newspaper outlets portray politicians, whether they were portrayed happily or angry, and how that aligned with the party affiliations of their readership. And the author could show that different media outlets portrayed the politicians differently so that they aligned with their actual readership. I think that's a super interesting thing to figure out. And then there's another paper coming up, and they look into how people react to debates. So like a TV debate of politicians. How does their facial expression gain or lose them approval? This would be another thing to show or to look into. Yeah, and I think that there would be two applications that come from the top of my head. I'm also working on a paper where I was looking if, given the same thing politicians are saying, but with a different tone, with a different facial expression, whether that changes the attitude of people towards the politician. So I'm mostly using it as one measurement of how emotional or what emotion is being sent by the politician. And of course, you can transfer emotions with more than facial expressions. There's always a tone, there's content. But I think usually facial expression, tone, and content match. So this would be just one way of measuring what is sent basically by a politician, just like we would use sentiment analysis of text. Was there a second part?
Yeah, there was a second part, and there's actually another question that kind of goes in the same direction. So it's basically, do these algorithms also work on videos, or is it only static images?
Oh,
so
yeah.
Get dynamic in a
right.
sense.
So this is something that goes into this black box problem. We don't know on what kind of images those algorithms were trained. At the moment, it looks like it would actually work. There are problems to it, of course, because, for example, the mouth gives a lot of information. So if someone looks scary or angry, then the mouth position gives information to the algorithm. And of course, if you're talking, you might have an open mouth without being scared. But there are some studies looking into how good this works, and they start to find that it actually does work quite well, even if people talk.
So what would be like to get an idea of that? I remember when we were working on this like little project that we had, we kind of like we cut the video in frames and looked into the several frames. And my idea would then be like, just out of my intuition, that you could probably average over these images to get an idea of the sentiment, or would you do it differently?
No, that would actually be, I think, the way to go. So I think, I haven't looked into it, but there are some providers that also offer you to send video. So, and then there, of course, the code and the algorithm is trained to work with video data. But if you wanted to use Face++ or Microsoft Azure, you would, as you said, cut the video into frames per second. I would say the more the better. So maybe at least start with 5 frames per second, but you could also go up to 20 frames per second, depending on how good your video material is. And then make averages per second or averages per minute. That again is a question you need to decide upon your research interest. So if you're really interested in what is the overall emotion transported in the speech, or maybe in this little segment.
Okay. Thank you.
But yeah, that would actually be the way to go.
Yeah. So then there's like, okay, so then there's kind of a follow-up question again. If I think of like cutting a video into the single frames, I probably might not have a high resolution image. So is there somewhat of a kind of threshold or a cutoff point when it's really hard for the algorithms to detect the emotions? So do I need a specific like resolution of the single images so that the algorithms work reliably?
So the manuals and the documentations, they give a minimum amount of pixels that you should have. And I think that would give you an idea of how good your resolution should be. But of course, a little bit of a better resolution is always better, especially if you cut videos, because then sometimes, depending on which program you use, the images get a little bit blurred, because they're like in the camera movement, for example. But then again, there is software that can take care of that, like FFmpeg, for example.
Okay.
But there are minimum resolutions, and they are stated in the documentations.
Okay, cool. Thank you. So there's another question by Verena. She asks whether you have experience or insights on the maximum number of faces that can be recognized. So let's say we have a picture of 200 people. Would that be like possible to recognize these in single faces?
So I know that for the free account, Face++ gives you the information up to 5 faces. For everything above that, you need to pay. And this is also where my expertise ends, because I never used the paid algorithm. But I think they also give you an indication of how large the face itself has to be recognized. And then I would guess that if there are 200 faces on the image, it has to be really high quality to be recognized. And then again, I would wonder if there might also be a maximum size of the image due to storage that you can buy. And I would say that for this kind of analysis, you would definitely have to pay. And then maybe if you talked or emailed the service, they might help you out with that.
Okay, thank you. Just talking about like storing images, do you like, I guess, or I kind of know that like storage capacity can definitely become a problem when it comes to this type of analysis or working with images. So do you have any like personal experience suggestions how like, let's say I'm new to this and I want to work with that. What should I do? What should I consider?
Basically have enough storage. So at some point, I decided to buy a computer that has 1 terabyte of storage, because that allows me to have a lot of my data on my machine. And then for what I'm doing, I just bought external drives, and that works really, really fine. And I mean, storage is not that expensive. You can get a proper external drive for 50 euros with 1 terabyte, and that brings you a long way. So I'm really just storing them as any other holiday picture on my machine or on external drives. It's, yeah, and then bring a little bit of time. Of course, cutting hours of videos into 5 or 10 frames per second takes a little while. But yeah, we're talking like the time I spent cutting really lots, like hours of videos, is, I don't know, a day or two to cut like 200 hours. So this is all still doable with reasonable amount of time without having to really think about how to fasten this process. It's still pretty doable and accessible, I would say.
Okay, yeah, this kind of gives an idea of what you probably need once you start working in that direction, right?
Yeah.
Okay, I think like, yeah, so there was also the suggestion that if you like storage, you can also run these scripts on BW Cloud if you're based in Baden-Württemberg, obviously. Yeah. Just another thing that came to my mind during the talk. So for Face++, you were saying that you can either access the image by the URL, so you can access them directly online, or as a file, right?
Yeah.
So I don't know if you have any experience with that, but is there a difference in the speed and how fast the algorithm works or
That is
not?
a good question. I have no experience with that.
Okay.
But my guess would be that it's not much of a difference, because what really kind of slows down the process is the system sleep at the end of the loop. And that you would have in any case.
Yeah, that makes sense.
Yeah. And so my colleague Sasha, he used it with the URLs, and at least we never had this kind of conversation where I say, oh, this code is running for so long, and he's like, oh, why? I can't imagine that happening. So yeah, that's all the experience I can share.
Okay, thank you. I think there are no more questions yet. So if anyone still has an unanswered question that we didn't tackle so far, or that I've probably overseen, just let us know. If not, like, thank you very, very much for this insightful talk. It was great, and I think it really gives you an idea of how easy, in a way, it can be if you have the code to use this alternative data source to get more information or add more information to your analysis.
Yeah, thank you so much for having me. And yeah, I can only encourage you, use it, play with it, figure out what the software provides. And yeah, I'm happy for every single researcher that joins this path. It's super interesting.
Okay, I think we're done for today, basically. Thank you everyone for joining us. Thank you for the fascinating questions, the insightful answers, Theresa, and thanks for being here.